So when they're not redeveloping some piece for the web, such as an XML reader that goes 30 times faster than the typical DOM Explorer, the Azure Maps team is giving you some new APIs. And Ricky is joining me today on the IoT Show to talk about how easy it is to integrate spatial data into Azure Maps. Hi everyone, this is the IoT Show. I'm Olivier, your host, and I'm joined today by Ricky. Ricky from the Azure Maps team. Ricky, how you doing?
Oh, I'm doing great.
So Ricky, for those who have not seen all the episodes that we've already been doing together, can you tell our audience a bit about yourself?
Yeah, I'm the principal technical program manager for the Azure Maps team, primarily focused on our developer SDKs and ecosystem.
Awesome, Ricky. So today you're here to tell us a bit about a new set of APIs for the Web SDK. So what is it?
Yeah, so we introduced this new thing called the Spatial I/O module, which extends our Web SDK and has a lot of great capabilities. And actually, I have a slide that with all these details. So the Spatial I/O module, as I said, it extends the Web SDK and adds in the ability to import and export common spatial file formats. So things like KML, KMZ, GPX, GOS, GML, CSV files, or delimited files that have spatial columns in them and well-known text. Yeah, you can even pass in zipped versions of these files as well, and it'll handle those quite easily. One of the cool things that we did as part of the creation of this library is we wrote our own XML and CSV reader writer classes, and the what we found was that the our XML reader was actually 30 times faster than the built-in DOM parser in the browser. And you might be wondering, why isn't that DOM parser faster? And the reality is when we're working with data files, they should be well structured, whereas the DOM parser, when it parses the HTML, can't always be considered well formatted. People make mistakes, and so with the XML reader, it able to make the assumption that the data is well formatted and read through it much faster than the DOM parser. So it allows us to support very large XML file formats for spatial data. The last feature is the ability to connect to some common OGC services. So for those not familiar with OGC, it stands for the Open Geospatial Consortium, which is a body that has a bunch of open standards for geospatial services. And so we allow you to, or made it easy to overlay web mapping services and web mapping tile services. Looks like I made a typo there. Also known as WMS and WMTS. We also have web feature services and the ability to query those, also known as WFS.
So I know you for being a demo guy. So I guess we're going to jump into some demos to show all you the APIs, right?
Yeah, I have lots of demos to go through. So let's take a look. All right, so we'll start off with a really simple example here where we've taken an XML file and overlaid it on top of the map. And nice and simple, just a bunch of points inside the data set. One thing you might notice, though, is a couple of these points are different colors, so they're actually green rather than blue. Maybe a bit difficult to see. If I zoom in here, maybe you'll see the difference a little bit better. And so, there's a little bit of data logic going on somewhere, where somewhere in the data set might actually say that the color should be green rather than no color specified or the color blue. So let's take a look at how complex it is to create this data-driven UI with the spatial I/O from our XML file. So the first thing we do is we add script reference to the spatial I/O functionality into our application. We have a bunch of our standard goodness for adding Azure Maps and rendering a map. We create a data source, which is where you're going to load all the data in once it's been read, and then a layer to render it. And so we introduced this new thing called the simple data layer. And behind the scenes, this actually wraps a bunch of our different rendering layers inside of our map control, and has a whole bunch of data-driven expressions that looks for certain properties. So if there's a color property, for instance, or on the data, it'll use that to set the color of that shape on the map. And there's a whole slew of different style options that we look for, and style properties that we look for within that layer. And the key thing is that's a massive amount of code that's all compressed down into a single line of code. So you take that, you can add that to the map, and that makes it really simple to do our rendering of this data that may have different formats and different styles assigned to it. From there,
Let me
we have
let me
this.
ask let me
Yep.
ask you real quick. So you're saying it's a huge amount of things that are in a single API, but what would typically a developer have to do the equivalent of that one line of code here?
So if they, it would really depend on if they knew the data ahead of time. So if they know that, all right, it's only going to be point data, then they might use just the bubble layer inside of Azure Maps, and it could be one line of code as well. But if the data is more complex, maybe it has some points, it has some lines, it has some polygons. Now you're looking at a minimum of 3 different layers there. And if you want to start taking in consideration the possibility that there might be style information associated with each shape, then you start getting into tens to hundreds of lines of code. Yeah, and at the same time, if there's a developer knows what their data is going to look like, then using the regular rendering layers is probably a better approach, because then they can have less layers that are being loaded in the background. But anyways, going forward, so to read data, all you simply have to do is do atlas.io.read, pass in either a URL to your file like I have here, or pass in a string of your that has your data in it. You can also pass in an array buffer. So if maybe you've used the fetch API to download a zip file, you can take that blob of data and just throw it right at the reader, and it'll still read it as well. This uses a promise because it does a lot of processing up in a web worker to free up your UI thread. Also, if you're using things like KML, KML has what are called network links, and so it actually make calls out to load in more data. And so we need to do that inside of a promise because we don't know when those are going to respond. Um, and in any case, from there, it returns this data set, and so I just have R for response, and I can just simply pass it into the data source. So this data set is essentially what's called a GeoJSON feature collection. We've added a couple additional properties to support some additional information that might come through KML, so things like ground overlays and icons URLs, which we can then use to enhance it. From there, all I did is I took the bounding box information of that feature collection and set the map view on it to zoom into, and that's more of a just to make it easier to view what where that data is relevant for. But now let's take a look at a more complex scenario. And so here we have an example with the KML on the map. And so now we have, polygons, we have lines, we have icons, and for points and custom icons, and they all have, descriptions that are, and actually I think some of these are actually data-driven descriptions based off of properties, and all that, complexness of that KML file is actually fairly easy to support as well. And so taking that last example we had, we had the simple data layer again. But now we're going to work with a KML file that actually is referencing external resources. So like in this case here being the icons, but we could also be pulling in a network link that might be hosted on another server. If that server doesn't support cores, we need to use a proxy service. And so you can pass in a proxy service into the read request as an option. Again, we get back the data, but what we want to do is take a look and see, is there any icons in the KML file? And if there is, we then have to load those into the map. And so we can go through here and say map.imagesprite.add, and whatever the key is for the icons and or whatever the name that we've associated inside of the data, and then pass that icon into the map resources. I'm doing this in parallel with the promise all, just to make things a little bit faster rather than synchronous. But now that loads all those custom icons into the map resources so the map can render them. From there, I can also add my features into the data. And actually, I probably don't even have to do r.features. I could have done just r, and it would have understood it. And then finally, I can add ground overlays. Now, ground overlays don't go into a data source because they're actually a rendering layer of their own. And if you're not familiar with the ground overlay, in Azure Maps, we call them image overlays, but they're essentially an image that has each corner has its own coordinate. And so it's an image stretched out over the map. And as you pan and zoom, that image stays in place. So it's a great way of taking an image like a drone, taken from a drone, and placing it over the map so it stays in position. And so you can kind of see where it is, and everything stays relevant. So slightly expanded example, but now it supports all the advanced features of KML with the custom icons and ground overlays. Going further, let's take a look at a couple of cool examples here. And so the first one is a KMZ file of the New York City Metro, and so it's downloading the data actually directly from a public website. And here we are. We have this, all the different colored transit lines, and we have the different colored icons for the different stops. All nice and simple. And with Azure Maps, we can view it from different locations or directions and rotate it. Taking a look at another example, so we have that San Diego fire one again, being pulled in very easily, as well as more advanced things. So this is actually um, all the internet users drawn as a choropath, or sort of a 3D choropath. So each country being a polygon, or being rendered as a polygon that's stretched up with a height, and so it's kind of like almost like a 3D bar chart, but based on country boundaries. Yeah. In this example here, we see a ground overlay. In this case, this is actually, I think, the architectural diagram for all the pillars of this cathedral. And so it's actually just an image stretched out over a set of coordinates so that we can, as we pan and zoom, it stays in position.
That's the Notre Dame Cathedral in Paris, and
Yeah,
it burnt. Well, some of the roof burnt last summer. But I was wondering, like, in thinking about that, all of that data is static, right? This is data that exists somewhere in your load. So
right.
how do you as a developer approach the fact that some of that data is dynamic? You had the metro, information in that previous map for New York. So can you, or is it easy, and can you use the same APIs to load dynamic data and work with dynamic data?
Yeah, actually, it's pretty easy. So in this case here, where I was doing the New York City Metro, all I have in my application here is a URL pointing to a file that's sitting somewhere else, and that file sitting at the New York City Metro website. And so I'm literally just pointing to a file somewhere, and if it's being updated every time I load the map or every time I call that read function, it's going to grab the latest data. And so, and this is actually fairly common. A lot of government agencies like NOAA make files available in KMZ file format, and they update them every hour or every minute, depending on the type of data. And so you could simply just point to it, and then if you wanted to in your application, set up a timer that maybe every 5 minutes it just goes through and reloads that data, and it'll just make a new request and download the latest data from the service.
So it's basically dynamic by default, basically.
Right. So moving on, taking a look at the OGC map layer example. So we can do, WMS and WMTS overlays, and these are essentially image overlays on top of the map that use this. The WMTS uses the same tile system as the map. WMS actually just generates an image of a certain size, and then we've done some magic to geo-reference it inside of our map control and overlay it so it looks nice and seamless, so we can pan and zoom in on this data set. And as I zoom in, we can see it. You might be able to notice it gets a little blurry, and then it snaps in, and it actually goes through and loads in a new image there. And what's nice about supporting these is there's hundreds of thousands, if not millions, of services out there that expose a ton of open data in these formats. And so let's take a look at how easy it is to use the OGC map layer. So essentially, you create an instance of that layer, and you pass in a URL to wherever that service is. From there, there's a lot of optional functions that you can pass in, and I've passed in a couple of them here. One of them is, I can say I want it to set the active layer to a certain one right away, because some of these services will have hundreds of layers of data in it, and you specify which layers you want to be rendered. I also have the option here to say bring it into view. So when I load that data or get the capabilities, it tells me what the bounding area is of where that data is available. So I can use that to kind of set a rough view of where to look for the data. And then we have a debugging mode. So there's a lot of different versions between these services and a lot of different functionality that some services provide that isn't quite standard or doesn't align correctly to the schema. And so what we've done is we've written a ton of code to try to handle all these different scenarios. And but with that, sometimes it has to do a lot of different testing. Like, for example, in this URL, I'm just passing in literally the domain. I'm not passing in any information on how to get the capabilities. If I made the URL longer with more information, then I'd be able to say, okay, I know how to call that service easily. But without that information, I have to go through and do some testing behind the scenes. And so the debugging information, when it turned on, will actually tell you what it's doing in the console. So you can go through and understand. So if something doesn't load, you'll see in the debugger or in the console why something's not loading, or where it's having trouble trying to figure something out. What's also pretty neat is the web WMS or web mapping service actually has a support for what's called get feature info. And so basically you pass in a pixel coordinate and it'll tell you all the information that it has on that for that coordinate. Now, not every WMS service supports that, but some do. And to actually use that with Azure Maps, we've set up a nice little helper function where you just say layer.get feature info. You pass in a coordinate or a geospatial coordinate. Behind the scenes, we'll turn it into the correct pixel coordinate and then request that data from that service. And then we return that back as a GeoJSON object, so that's very easy to then render it on the map or retrieve the properties that are returned. Moving forward, so let's take a look at a couple of examples of OGC services. So the first one we're going to take a look at is the World Geology Survey. And this one here is a really rich map. So it's just loading in a lot of the data here, and for some reason it loaded there.
You were on the wrong dimension of the planet.
Yeah, I guess so. To be honest, I haven't had my tried this demo on such a small screen size. But as we can see here, so there's a legend here showing us what all these colors mean, and there's hundreds of different colors here, and then there's actually a couple other layers in here as well. But this is a really nice, colorful image. With a ton of data being pulled in from an open service that's provided by, I think, the U.S. Geological Survey. And so we have all this nice information that behind the scene, all I really had to do to load this was pass in a URL into the OGC map layer. Additionally, let's take a look at a more advanced one. So let's take a look at actually, I say more advanced, this one here is a WMS service with topo, US topo availability. So it tells us where the topographical data is available. And we'll zoom in here. And one of the neat things here is it supports clicking. So now I've clicked on the layer and it's told us what the feature information is for the pixel coordinate that I clicked on in that image. And so we have a ton of data in there, and it even has images in here of showing us the topographical maps of that area, and a whole bunch of other useful information. And literally that code sample I showed previously, that's all I had to do to get all this set up. The last thing I wanted to show is the web feature service functionality. And a web feature service essentially is a glorified web service that has a lot of support for spatial querying. And so I can go through and say, find everything within a certain distance or within a polygon, or do a simple property search. And so in this case here, I can go through and say, get the first 500 locations in the data set. And it goes through and does that. I can go through and do, some complex filters, and it'll go and retrieve whatever data matches that, which is a single item in this case. If we take a look at the code, all we have to do is we create an instance of the WFS client, because it's now a service rather than a map layer. We pass in a URL to where the service is. And so in this case, I put in the get capabilities URL. That's actually optional. If I just cut it off right there and didn't add on the query string, the service or the client would still understand and would figure out how to call that service. Now that we have the WFS client set up calling that service, we can go through, and in this case here, we want to figure out how we're going to query it and what filter we want to pass in. I've done a little simplification here where I've just short formed the filter namespace, so that I don't have to keep writing that over and over again. And we go through and take a look at a couple of the different filters. So in this case here, the query is taking a look at the type name property of the service and passing in, what layer or what data set I wanted to query. And I'm asking for the first 500. So that was the first example we looked at. Taking a look at a more advanced one. So this one here, again, I'm passing in what set of data I wanted to look at. And then for the filter, I'm going through and doing an and filter on a fairly complex example here. And so what this is doing is it's checking to see if the pop property is It's dividing it by 1,000 and seeing if it's greater than 2. So basically, is it greater than 2,000? So just doing a little bit of a math as part of the query, and then it's also checking to see if the number of households in that polygon or that area is greater than 500. And so now a fairly complex query that's written down very simply here. Or fairly simply, and there's more complex ones here, or more advanced ones we can do. In this one here's doing a bunch of checking if a bunch of different property names equal different things, or in this case here this is doing the like a free form string where it's going through and doing like a like type query. So you can think of SQL Server and how you would do a like query there, and you have your placeholders for additional information beyond the text or the values I've provided, and so all that's fully supported here as well. So now if we take a look at this process query function I added in here just to simplify my example, all it does is take the client, it says get features, and it's passing in that request. So that all these different information or options I've been creating, passes it into here, and then it returns a feature collection with my data. And then from there I can add it to the map, I can set the view of the map. It's really just that simple.
Ricky, that was indeed a very comprehensive set of demos for these new set of APIs to include and easily include spatial data. We were not lying in the title into Azure Maps. So we have a link here, which is aka.ms/iotshow/special data in Azure Maps for you to get to the documentation. Ricky, I hope you're going to join us again soon on the IoT for more episodes and with more Azure Maps data, right?
Definitely.
And to everyone, thanks for watching, and don't forget to subscribe to the IoT Show. See you soon.